Today, we're tracing a truly wild trajectory. We're mapping the journey of Elon Musk, starting all the way from his earliest days tinkering with code in South Africa, right up to how he fundamentally redefined the economics and, honestly, the entire future of space travel. Let's dive right into this. Listen to this intense confession from a 2017 aerospace conference. He said, "I messed up the first 3 launches. The 4th launch worked, or that would have been it for SpaceX." It's so easy to look at the massive valuations today and just assume it was a smooth ride. But this really illustrates the sheer existential risk SpaceX faced back in 2008. They were down to their last dime. But to understand how he even reached that precipice, we actually have to rewind the clock a bit. Part 1. Foundations of an Innovator. He moved rapidly, both geographically and academically. Born in Pretoria in 1971, he made a major life decision by 1989. To avoid mandatory military conscription during the apartheid regime, he used his mother's heritage to obtain a Canadian passport and emigrated. From there, he transfers to the University of Pennsylvania to study physics and economics. Then, he heads to Stanford for a PhD in 1995. But, get this, he drops out after just 2 days, realizing the internet boom was where the future really was. That technical intuition didn't just suddenly appear in college, though. His worldview was heavily shaped by grand science fiction epics like Isaac Asimov's Foundation, which really planted the seed of thinking on a planetary scale. Combine that with the fact that at age 10, he'd literally taught himself to program from a Commodore VIC-20 manual. By 12, he had coded a space video game called Blaster and sold it for $500. This intense, self-directed learning was the exact foundation he'd need. Moving on to Part 2, the Crucible of Capital. So, in 1995, after leaving Stanford, he founds his first software company, Zip2, alongside his brother Kimball and Greg Corey. I really want to emphasize just how grueling this startup was. They started with about $2,000 and an overclocked, home-built PC. Musk literally slept on the office couch and showered at the local YMCA because they just couldn't afford an apartment. He coded 7 days a week. It was an absolutely brutal grind, but it set up a massive payoff. Zip2 ends up being acquired by Compaq for over $300 million, netting Musk $22 million. Now, does he just retire to a beach? No way. He immediately rolls that into co-founding X.com, which merges with a company co-founded by Peter Thiel to become PayPal. When eBay buys PayPal in 2002 for $1.5 billion, Musk walks away with over $175 million. This incredible progression of wealth, that is exactly what he had to risk to even dream of going to space. Which brings us to Part 3, the Falcon 1 struggle. Because, as it turns out, space is hard. Getting to orbit is incredibly unforgiving. Flight 1 in 2006, a corroded aluminum nut leaks fuel, causing an engine fire just 25 seconds in. Flight 2 in 2007, propellant sloshing in the tanks leads to an engine flameout. Flight 3 in August 2008, well, they fixed the slosh, but a tiny timing error, literally just a second or two, means the first stage physically collides with the second stage during separation. 3 strikes. And the toll this took cannot be overstated. By late 2008, both SpaceX and Tesla were teetering on the absolute edge of bankruptcy, right as the Great Recession hit. Musk actually described his period as waking from nightmares, screaming, and in physical pain. The stress was immense, and the money was almost entirely gone. But then we hit September 28, 2008. SpaceX scraped together enough parts in 6 weeks for one absolute last chance. Flight 4 of the Falcon 1 launches from the Pacific and successfully puts a 165-kilogram dummy payload called RATSAT into orbit. It became the first privately funded liquid-fueled rocket to achieve Earth orbit. It was the launch that literally saved SpaceX. Let's look at Part 4, SpaceX's key contributors. Because this transition from survival to industry dominance was definitely not a solo effort. Gwynne Shotwell played an absolutely vital leadership role here. Just a few months after that 4th flight, she successfully negotiated a massive $1.6 billion commercial resupply contract with NASA. Named company president, she provided the exact financial lifeline they needed to focus entirely on the Falcon 9. It was her leadership combined with engineering teams rigorously executing Musk's internal algorithm for relentless, iterative innovation that allowed the company to scale. All right, Part 5, architecting rocket reusability. Historically, rockets were entirely expendable. It's literally like flying a 747 from New York to London and then just throwing the plane away. Crazy, right? Well, SpaceX changed that. In December 2015, they achieved the first orbital-class retropropulsive landing. Soon, they were landing boosters at sea on autonomous drone ships, with these poetic sci-fi names like Of Course I Still Love You and Just Read the Instructions. By 2018, they scaled this up to the Falcon Heavy, launching a Tesla Roadster into space. And by 2020, they returned human spaceflight to U.S. soil with Crew Dragon. Reusability completely drove the cost of access to space into the floor.
And finally, Part 6, the Starship Frontier.
Starship is really the realization of those childhood sci-fi dreams. It is the largest and most powerful rocket in human history, powered by a massive cluster of next-generation Raptor engines. They actually made a huge engineering pivot to use stainless steel for the hull, just to withstand extreme reentry temperatures, eventually culminating in its iconic belly-flop skydiving maneuver through the atmosphere. Their whole philosophy? Launch, push it to the limits, blow it up, and learn. All of this is designed specifically to fulfill his ultimate vision, colonizing Mars. We've seen how a kid reading Asimov in South Africa turned software fortunes into the rockets that disrupted a stagnant industry, and how close it all came to total failure. Looking forward to the Starship era, you really have to ask yourself, will this immense, almost unbelievable tolerance for risk ultimately be the thing that makes humanity a multiplanetary species? Definitely something to think about. Thank you for joining me on this explainer, and keep learning.